All right. Today's lesson focuses on coordinate planes and introducing you to the coordinate plane. And that's what we have here in front of us is a coordinate plane. It is created by two number lines that intersect. And our horizontal number line is the one that goes left to right. That is known as our x-axis. And then our vertical number line, the one that goes up and down, that forms our y-axis. The point here where they intersect, that is our origin. And that's where you start from when working in the coordinate plane. The intersection forms four sections, and these sections are known as quadrants. The quadrant here in the upper right, this would be quadrant 1. And you'll notice that our quadrants are labeled with Roman numerals. The quadrant to the upper left, this would be quadrant 2. As we move counterclockwise, the quadrant in the lower left, this is quadrant 3. And the quadrant in the lower right is quadrant 4. And again, you'll notice our quadrants are labeled with Roman numerals. So for our lesson today and our next lesson, our objectives are to name and locate points on the coordinate plane, and then our next lesson will focus on drawing and identifying polygons on the coordinate plane. And we do have a few standards that we'll be addressing in these two lessons, and I'll just kind of scroll through those here. Very similar to our lesson objectives that we have listed above. But this is what we will be working on over the next couple days. And then mainly this bottom one here is for our day 2 assignment, which will be coming up later. So on this page here is just kind of a repeat of what we did on the coordinate plane at the beginning. It's made up of two number lines. The horizontal is called the x-axis, vertical is called the y-axis, the intersection is the origin, and then the four quadrants. And then the one final piece with the coordinate plane that we want to define before we go any farther is the idea of the ordered pairs. An ordered pair in the coordinate plane is made up of two coordinates. That's why it's called an ordered pair. The first coordinate in our ordered pair is the x-coordinate, and the x-coordinate is based on where you're at on the x-axis, or that horizontal line, which makes our second number, our second part of the ordered pair, the y-coordinate. And the y-coordinate is based on how far up or down you go in relation to the y-axis, or that vertical line. So here we have a coordinate plane, and I apologize that you can't see all of it right now, but I will scroll to see some of the other points that are on here that we'll get to in a minute. But we want to do two things on our coordinate plane here. We're going to identify the ordered pairs and also note the location of each point on the coordinate plane. So we'll start with point A. So for point A, if we start, we're always going to start right here at the origin. And we always do our x-coordinate first. So if we were going to move from the origin to point A, I'm going to move across the x-axis first. So I'd have to move to the right, and I have to move to the right 2 places. So my x-coordinate for A is 2. I have to move 2 places to the right on my x-axis. And then to get from the x-axis to A, I would have to move up, and I have to move up 3 places. So the ordered pair for A is 2, 3. Point A lies in quadrant 1, because it's in that upper right quadrant. So for B, I once again come to my origin, which is the area that I've circled there. And for B, I first have to move to the left. Well, as you notice, as we move to the left, those numbers are negative. I still move 2 places, but this time, since I'm going left, which are negative, my x-coordinate is -2. And to get from the x-axis to B, I move up 3. Well, those are still positive, so my ordered pair for B is -2, 3. And B is in quadrant 2. So my next point is C. I'm going to scroll just a little bit so we can see C a little bit better down here at the bottom. For C, I once again come back to the origin. And to get to C, I move 2 places to the left first. So once again, my x-coordinate is -2. And to get to C, I'm now moving down on the y-axis. And as I go down, you can see those numbers are negative numbers. And I move down 3 places. So the y-coordinate for C is -3. And that puts point C in quadrant 3. Point D, I come back to the origin. Again, the origin is that circled area I have on the coordinate plane. And I move to the right 2 places. Well, since I've moved to the right, that is a +2 once again. And I go down 3. So my y-coordinate is once again -3. And that puts D in quadrant 4. My next point is E. So for E, once again, I come back to the origin. I move to the right along the x-axis. I have to move 5 places to the right, so that puts my x-coordinate as 5. And then E, I don't have to move up or down, so my y-coordinate is 0, which places E on the x-axis. E does not fall in one of the quadrants, it is on the x-axis. For F, once again, I start at the origin. For F, I don't move at all to the left or to the right, so my x-coordinate is 0. And then I move up 5 places, so my y-coordinate is 5, and point F is on the y-axis. For G, come back to the origin. I go to the left 5, so the x-coordinate is -5. The y-coordinate is 0, which puts G on the x-axis. And then our final point, which is down here, so I need to scroll down. There's H. You can see H down here at the bottom. I don't move from the origin to the left or to the right, so my x-coordinate is 0. I move down 5 places, so the y-coordinate is -5, and that puts H on the y-axis. So those are our ordered pairs and our locations for these points. Okay. I'm going to clear this page real quick because there's a little bit more that we can do with our coordinate plane here. And what we're going to look at now are known as reflections. Well, normally with a reflection, you need a mirror. Well, our mirrors for this lesson are going to be the x-axis and the y-axis. So if we look at point A and point B are reflections. But we need to determine what our mirror is. Well, they are reflections across the y-axis. Because if you go from A to B, you have to cross the y-axis. So therefore, A and B are reflections across the y-axis. Now we've already established that A's ordered pair is 2, 3. B's ordered pair is negative 2, 3. Well, we're saying that A and B are reflections across the y-axis. Notice their y coordinates. Their y coordinates are exactly the same. Their x coordinates, though, there is a connection between their x coordinates. And if you notice, their x coordinates are opposites. So if we look at some other reflections, let's see if that stays the same. Well, C and D are also reflections across the y-axis. C's ordered pair is negative 2, negative 3, as shown before. D's ordered pair is 2, negative 3. So both C and D have a y-coordinate of negative 3, which means it does not change. But their x-coordinates are 2 and negative 2, which are opposites. So what we can establish here is that when you're reflected across the y-axis, your y-coordinate does not change, and your x-coordinates would be opposites. Now we have one more pair of reflections across the y-axis. Let's see if this stays true. Our final pair that's reflected across the y-axis is E and G. Well, the ordered pair for E is 5, 0. Ordered pair for G is negative 5, 0. So once again, our y coordinates are the same. Our x coordinates are opposites. I'm going to clear a couple things here again. Now we don't just get reflected across the y-axis, but we can also have reflections across the x-axis. So A and D are reflections across the x-axis. So once again, we look at our ordered pairs. A is 2, 3. D, which is down here, is 2, negative 3. We're reflecting across the x-axis. Our x coordinates are the same. Our y coordinates are opposites, very similar to when we reflected across the y-axis. So this time, since we're reflecting across the x-axis, it's the x coordinates that stay the same and the y coordinates that'll be opposite. So if we look at our other pairs of reflections, let's see if that holds true. Another pair that's reflected across the x-axis are B and C. Well, B's ordered pair is negative 2, 3. C's ordered pair is negative 2, negative 3. So their x coordinates are both negative 2, and their y coordinates are opposites. And the final pair is F and H. And if you remember, H is all the way down at the bottom. So let's scroll down so we can see H. The ordered pair for F is 0, 5. Ordered pair for H is 0, negative 5. X coordinates are the same. Y coordinates are opposites. When writing ordered pairs, the order does matter, which is why they're called ordered pairs. Make sure when writing ordered pairs, you always put the x coordinate first, because the ordered pair of 2, 3 is not the same point as 3, 2. We have a coordinate plane here, and we're going to identify the ordered pairs along with the location of each point. So we're going to start alphabetically. We're going to start with P. So the ordered pair for P. Oh, sorry about that. Let's get rid of that real quick. Let's re-scroll down. Happens sometimes with the smartboard. All right, let's try that again. The ordered pair for P is 3, 0, and it is on the x-axis. For Q, our ordered pair, we go to the left 3 first, so that's negative 3. Then we go up 3. So our ordered pair is negative 3, 3. And Q is in quadrant 2. For R, our ordered pair would be in -5, 1, and we are once again in quadrant 2. For S, our ordered pair would be -6, -4, and we are in quadrant 3. T all the way down here has an ordered pair of -4, -7, and it is in quadrant 3. U, which is over here on the right hand side, has an ordered pair of 4, -5, and it is in quadrant 4. And V has an ordered pair of 3, -2, and is also in quadrant 4. Now for this next part, we'll be going back and forth between 2 slides because number 2 asks us to plot points on a coordinate plane. I have a coordinate plane on the next slide here, so we're going to be going back and forth. So for point A, we want to go to -4, 3. So if I go to my coordinate plane here, my x-coordinate is -4, so I come to the left, 1, 2, 3, 4, and then I go up 1, 2, 3. I plot my point. I label it as point A. Point B is at 3, -4. So for B, I start at my origin. I go to the right, 1, 2, 3. Then I go down 4. Let's scroll down a little bit, just make sure that I have some room there. 1, 2, 3, 4. There is point B. Point C is at 5, 0. So for C, I just come out to the right 5. 1, 2, 3, 4, 5. And there's C. D is at 0, -5. So I'm going to scroll down a little bit so I can get D on here. So since the first coordinate is 0, I don't move to the left or right. Also, I come down 5. 1, 2, 3, 4, 5. Well, didn't want that to happen, but figured that would happen eventually on this again. Sorry, smartboard can be a little bit touchy. Let's try that again. 1, 2, 3, 4, and 5. So there's D all the way down here. E is at -2, -1. So I'd go to the left 2, and then down 1 for E. And finally F. Oh no, not finally F. Oh yeah, F is our last one. Sorry about that. F is at 2, -1. So I go to the right 2, and then down 1 for F. Now for my reflections. Now for your reflections, you can put them on a coordinate plane, but you don't have to. If you just identify which axis you're reflecting across, you can remember the connection we made earlier. So if it's reflected across the x-axis, the x-coordinate stays the same. So if my x-coordinate's -6, it's going to stay -6. And then your y-coordinate uses the opposite. The opposite of 2 is -2. So for B, we're reflecting across the x-axis. So the x-coordinate stays the same. Use the opposite of your y-coordinate. The opposite of -4 is 4. For part C, x-coordinate stays the same. Opposite of your y-coordinate would be -5. For D, x-coordinate stays the same. Opposite of -3 is 3. And finally for today, we're reflecting across the y-axis. So this time the y-coordinate stays the same, and you use the opposite of your x-coordinate. Opposite of -6 is 6. 2 stays the same. Opposite of -2 is 2. -4 stays the same. Opposite of 4 is -4. 5 stays the same. and the opposite of 7 is -7, and -3 stays the same. So that's our lesson for today, and just like the other times, and as always, I hope this helps.